Hello viewers, I hope all are fit and fine. All are fighting this urban battle by staying inside the room and avoiding the pandal hopping in this festive season. So today I'll be describing about the network analysis. In my previous video I have explained about the various network diagrams, and from those network diagrams I'll be coming to this network analysis. In this network analysis, I'll be describing about the forward pass and the backward pass, and I'll also describe how from this forward pass and backward pass we will go to the critical path of the activity. Actually, forward pass is nothing but the earliest event time of the activity, and the backward pass is the late event time of the activity. And the difference of this forward pass and the backward pass gives you the slack, which is applicable in AOA diagram. If you don't have any idea about what is AOA and what is AON diagram, then please refer to my previous video where I have elaborately explained about this AOA diagram and the AON diagram. Today I will take one example, and from that example I will go stepwise about the various forward pass and backward pass, and from there I will count the slack, and from that slack I will find out the critical path of the activity. So I hope this will be very much handy for the aspirants, and please concentrate to this video and watch till end. I hope, I think I'll be optimistic. I will be able to give you something, some content that will make you inspired about this critical path method, which you cannot ignore if you are in this Let's take one example. Suppose this is activity A, B, C, D, E, F, G, H, I, and these are the interprecedence activity. A is having nil interprecedence activity, B is dependent on A, C and D, C is having nil interprecedence activity, D is nil, E is dependent on C and D, F is dependent on D, G is dependent on F, H is dependent on B, E and I is dependent on GH. And their respective durations are 6 units, 3 units, C is 3 units, D is 6 units, E is 2 units, F is 4 units, G is 3 units, H is 6 units, and I is 5 units. So if in a project you find this type of situation, then how to deal with this? How you will go for the network analysis? The step for this is you have to introduce one column for the sequence steps. This is called SS, sequence steps. Now the activity having IPA nil will be marked as sequence steps 1. So here A is having no IPA, so A will be marked as 1. Again, C is having no IPA, so C will be marked as 1. D have no IPA, so D will be marked as 1. And the activity that having the IPA marked as SS1 will be marked as SS2. Similarly for the case B, here the IPA is A, C and D. A, C and D have the sequence steps number 1. So B will be marked as sequence steps number 2. Again, the activity E is dependent on C and D, and C and D have the sequence steps number 1. So E will be marked as sequence step number 2. F is having IPA D, and D is having sequence step number 1. So F will be sequence step number 2. Now G is having IPA F, and F is having sequence step 2. So G will have sequence step number 3. Now H is having sequence step number B, E and I, where B and E are having the sequence step number 2. So H will have sequence step number 3. And I is having sequence step number G and H, and G and H are having the sequence step number 3. So I will have sequence step number 4. So in this way you have to find out first the sequence step number. So the basic concept for finding the sequence step number is, I'm repeating once again, the activity that is having a nil inter-precedence activity will be marked as sequence step number 1, and similarly the activity that has IPA of sequence step number 1 will be marked as sequence step number 2, and the activity having the IPA of sequence step number 2 will be marked as sequence step number 3, and vice versa. So now you have to segregate the sequence step number 1 in one column, sequence step number 2 in other column, and sequence step number 3 in another column, and sequence step number 4 in another column, and you have to connect all these things by means of a dummy activity. So how it can be done? So sequence step number 1, the activity A, this activity A is under sequence step number 1, and sequence step number C is under activity 1, and sequence step number D, this is also in activity number 1. So this is for sequence step number 1. Now the activity for sequence step number 2, it is activity B, again activity E, and activity F. All this comes in the sequence step number 2. Now for the sequence step number 3, that is activity G and activity H. This all comes in the sequence step number 3. Now the activity for sequence step number 4, there is only one activity under sequence step number 4, that is activity I. This is sequence step number 4. Now we have to connect all these activity by means of a dummy activity. Now this B is dependent on A, C and D. So let's connect B with a dummy activity, that is A. Let's connect with a dummy activity from C and a dummy activity from D. Now this again E is connected with C and D. So this is E, this is connected with dummy activity, this is C, and with dummy activity D. Then F is connected by D. So F will be connected by dummy activity D. Then G is connected by F. So this G, this will be connected by dummy activity F. H is connected by B and E. This H is connected by B, dummy activity B, and dummy activity E. I is connected to G and H. This is connected by dummy activity G, connected by dummy activity H. So all these are connected by dummy activity. All these sequence steps are connected by means of dummy activity. So now if you have a doubt about what is the dummy activity, then please refer to my previous video where I have explained in detail about the dummy activities. Now the next step is to avoid the dangling of activity, we have to fix one start and one end point. So now this network will get converted into another network that will have a single start point and single end point, and we will look to avoid the maximum dummy activities that can be avoided. So let's start it in this way. Let's start with a single starting point, and from here we'll get another point that is known as A, and from here we'll get another point that is called C. We'll get another point that is D. These are activity A, C and D, and these activities will be connected with dummy activities. So these are connected with the means of a dummy activities. Now Let's move to another activity. This is activity B. This is activity E. This is activity F. Let's connect this E and F by means of a dummy activity. Then we'll have another activity, that is this activity known as H, and this will be connected by the activity called G, and finally it will get to another activity called I. So now we will here we have minimized the number of dummy. Here only we have used 1, 2 and 3 dummies, and now let's number it. So this will be 1, this will be 2, this is 3, this is 4, this is 5, this is 6, this is 7 and this is 8. So while numbering this, the due care should be taken about the I and J, that is the tail event should be lesser than the head event. I have explained all these things in my previous video. So if you have any confusion about this, please refer to my previous video. So this is the final network. From this network, we will go for the analysis to find out the slack, and from that slack, we will find out the critical path and the critical activity. Now let us write the duration here. This is the duration of this activity. This A is having the duration of 6 units. This B is having a duration of 3 units. This C is having a duration of 3 units. D is having a duration of 6 units. E is having a duration of 2 units. F is having a duration of 4 units. Then G is having a duration of 3 units. H is having a duration of 6 units. And I is having a duration of 5 units. Now from here we will go for the backward pass and forward. Now before going to the backward pass and forward pass, I will try to give one figure of what is the difference between the representation and analysis. So this representation is this. Suppose this is one node and this is another node. This is activity. This is suppose activity A, and if a duration is written below, this duration will be dA. Now for the analysis part, we represent this network in such a way. This is earliest event time EET, this is late event time LET, and this is known as the slack. And this is connected by another nodes that is also having the same thing. This is the earliest event time, and this is the late event time, and this is the slack. Similarly, this can also be written in the reverse direction. That is, you can also represent it in this way. That is, here is EET and here is LET, and this is slack. The thing is same, and similarly this will be represented by another sequence, another nodes that is having EET, LET and slack. The thing is same. So this is how this is a network and this is analysis. So we will now go for this assumption of what is the assumption of the forward pass. We will go for the assumption of the backward pass, and then we will analyze the previous this activity duration to this the slack and we'll find the critical path. Now the assumption of forward pass. The forward pass should move from left to right. The forward pass should start from 0. This is forward pass is the maximum of the preceding activity plus duration. So let's represent here the same network diagram we have represented here, and we will do the forward pass. So this is the earliest event time, so we will start here from 0. So this forward pass here is the maximum of the preceding activity plus duration, that is 0 plus 6, so this will be 6. Again, for this activity, this is 0 plus 3, this is 3, and here for this activity, this is 0 plus 6, this is will also be 6. So here for this activity there will be 1, that is 6 plus 0, this is 6, this is 0 plus 3, 3, and so the maximum will be 6. So here 6 plus 3, that is 9. So here we will get 9. Again 6 plus 4, here we will get 10. So 10 plus 0, 1, we will get 10. And here is 6 plus 2, we will get 8. So the maximum will be 10. And this is 10 plus 6, this is 16. And here is 10 plus 3, that is 13. So we will take this 16. And this is 16 plus 5, this is 21. So these are all the forward pass. We have started from this direction, that is left to right. Now for the backward pass. For the backward pass, we have to start from the last late event of the activity, and we have to move backward and subtract the duration, and the minimum will be the backward pass. The backward pass moves from the right to the left. So here the last late event is 21. So we have to take here is 21, and 21 minus 5, this is 16. So here then is this 16 minus 6, this is 10. So here this is 10, so this is 10, and this is 16 minus 3, that is 13. So we have to take the minimum of this, that is 10. So 10 minus 4, this is going to be the 6, and here it is 10 minus 2, that is 1 is coming 8, and here it is 10 minus 2, 10 minus 3, that is coming 7. So 7 minus 0, so it is 7. So we have to take the minimum, that is this will be the 7. And here is 6 minus 6, this will be the 0, this will be the 0, and this 7 minus 3, this will be 4, and here is 7 minus 6, this will be the 1. So we will have to take the minimum, so this is 0. So this is the backward pass. So we have reached to the concluding part of this session. So now we have to calculate the slack calculation. Actually slack is nothing but the LET minus EET, that is the late event time minus the early event time, and the activity that is having a 0 slack is a critical activity, and the path the activity following with 0 activity is the critical path. So from this analysis we will find the activity with 0 slack. So this is the activity with 0 slack, LET minus EET is 0. Again this is the starting point, and this is activity with 0 slack, this is activity with 0 slack, this is activity with 0 slack. So the activity for the critical path, maybe this is D0 is dummy activity, that is D, we can say this is DF. There may be a critical path, we can say it's D, then F, G, I, or it may be D, F, H, I. Now DFGI is having how many units? This is 6 plus 4, this is 10. 10 plus 3 is 13, and 13 plus 5 is 18. So this is having 18 units. And this DFHI, 6 plus 4, 10. 10 plus 6, 16. 16 plus 5, this is 21 units. 21 units. So this is the critical path. 21 units. Actually, the critical path is the path having the maximum duration. That is the critical path. So DFHI, this DFHI, this DFHI, and this I, these are the critical path, and the time taken by the critical path to complete this activity is 21 units. Now one thing is very clear from here, that is this dummy activity sometimes causes a problem in AOA activities. I have already told earlier that this dummy activity is the drawbacks of the AOA activity. You see, we have already have a confusion here. Instead of taking that DFHI, one can also take DFGI, and in this on that case this duration will be of 18 units instead of 21 units. So there may be this may cause a confusion, and so this entire scenario will get changed if instead of DFHI you take DFGI and declare that DFGI is the critical path. Actually, the DFHI is the critical path. These dummy activities to be considered. So for going for the AOA activity, this thing is to be always keep in mind that dummy activity should be considered with due consideration. Otherwise, that may elicit to your answers. So I hope you have enjoyed the session, and your inspiration will help me to explore more on this subject. And if you are very much impressed by this video, then put the fat thumb on the like button, share this video with the others, and please do subscribe so that I get more inspiration. This is Devruda Chakraborty signing out till we meet again.